How do neural networks adjust weights and biases during training? Imagine teaching a child to recognize animals. You show pictures, tell them what each animal is, and they get better over time. Neural networks learn in a similar way. They start with random settings, then improve through practice. When a neural network begins training, it assigns random numbers to its weights and biases. Weights decide how much influence each input has on the output. Biases shift the output up or down, regardless of the inputs. Together, they shape how the network processes data. Next, you feed data into the network. It makes a guess based on its current weights and biases. Then, you compare this guess to the real answer. The difference between the guess and the actual result is called the error. The goal is to make this error as small as possible. To do that, the network uses a process called backpropagation. It calculates how much each weight and bias contributed to the error. Think of it like a teacher giving feedback on each part of a student's answer. The network then updates its weights and biases to reduce the error. It does this by moving each parameter slightly in the opposite direction of the error. This step is called gradient descent. The size of these small changes depends on a setting called the learning rate. If the learning rate is too small, the network learns very slowly. If it is too large, it might jump past the best values and never settle. Finding the right learning rate is key to good training. Biases are updated the same way as weights. Even if all inputs are zero, biases help the network produce a non-zero output. This ability allows the network to model more complex patterns. During training, the network processes many examples, often in groups called batches. It repeats this process many times, called epochs. Too few epochs mean the network might not learn enough. Too many can cause it to memorize the data instead of learning general rules. This process of adjusting weights and biases is how neural networks improve their predictions. It is used in large AI systems like ChatGPT, and Midjourney. These systems learn from huge datasets to generate text, images, and more. Even productivity tools use similar ideas to automate tasks. In simple terms, neural networks learn by making small tweaks based on feedback, gradually getting better at understanding and predicting data. This ongoing adjustment is what makes AI systems smarter over time.